All right, so in the previous two videos, we took components and brought them together to make one resultant magnitude and direction. That first video was just about the magnitude. The second was just about direction. But here at the end, we also want to go the opposite way. We want to take a resultant, a single vector, and break it down into just its x and y components. This is more of what we will do as we go throughout the unit. You do have to be able to do both, but this is what we're going to take with us as we go on into projectile motion. So let's say we had some situation, maybe it was a ball that was kicked at a 30-degree angle from the ground, and the speed the ball was kicked with was 45 meters per second. The question is, what is its x component? And what is its y component? Just like before, we're going to use our sine is opposite over hypotenuse. I'm just going to write out SOHCAHTOA. Our cosine is our adjacent over hypotenuse, and our tangent is our opposite over our adjacent. To do both of these, if I take and I draw out those components, here being the x component, and here being the y component, I've made a triangle. And I've got an angle and a hypotenuse, and I want to find those individual sides as well. So I'm going to start with my x component. That's this piece right down here. And if I'm dealing with the x component, I've got my adjacent side as well as my hypotenuse. So if I've got adjacent and hypotenuse, I want to start with cosine of the angle is the adjacent over the hypotenuse. I'm going to substitute in cosine of 30, because that's my angle this time, is my adjacent. I'll put an x because my x component, and my hypotenuse, 45. To solve for x, I multiply 45 to both sides, and then I take the cosine of 30, and that equals x. So if I get in my calculator, 45 times the cosine of 30 gets me 38.97. So my x component is 38.97. And because my resultant, that vector, was meters per second, it was a velocity, this is also a velocity. It is also in meters per second. Now to get my y component, I actually have two options. I could either now use the Pythagorean theorem, that a squared plus b squared equals c squared. I've got two sides. I've got this x side as well as the hypotenuse. I could do it that way. Or I could do another one of the trig functions. Personally, I prefer to do the trig here. I think it'll be a better example to sort of practice with, but the option is ultimately up to you. So again, here now I'm working with y. That is the sine of the angle, because I'm working with my opposite side and my hypotenuse. So the sine of the angle is the opposite over hypotenuse, SOH, sine opposite hypotenuse. So again, the sine of 30 is the opposite side, y, over 45. Multiply 45 to both sides, I get 45 times the sine of 30 is equal to y. And that gets me 22.5. And again, because our hypotenuse was meters per second, we also have meters per second for just our y component. This starts out as velocity. Each of these pieces is also velocity. So in doing the opposite way, if we're going from the vector to the components, we use the sine and the hypotenuse to do so. So hopefully this refreshes a lot of the same stuff you've already done in previous math classes. I apologize for not being here today on Friday. Your homework for this weekend is worksheet number 1. finish that. It is just triangles. It doesn't necessarily talk about it being a vector, but it's practicing the same skills using the sine, the cosine, and the tangent. On Monday, we will come back and tie a lot of this together. So enjoy, and we will see you on Monday.